In this video, we'll be looking at the solution of the combinatorial problems using generating function, or I can simply say that we want to count using the notion of the generating function. So to understand this, I'll recall first from the permutation and combination. Now permutation is where we are interested in counting with the arrangement in mind. So we want to arrange something, that means the order is important. So permutation, for the permutation we use the general symbol as NPR, and here the objects were not repeating. Similarly, in the combinations we said we want to select some object out of the given object, and here we use the word selection, and again order was not important, and we use the notion NCR. These were the notations for this. So here we have discussed further with repetitions and without repetition. So all these things I've already discussed in my previous videos, the link added in descriptions. In fact, we also used a concept of multi-sets. So when the objects are repeating, we can use the notation such as R1 into A1 and R2 into A2 and so on. Let's say some RK into AK. So there we can say that there are K objects and each object is repeating Ri times. So each object is repeating Ri times. This means objects are not distinct. So again, we can have the criterias like the objects are distinct or the objects are not distinct. And then we also discuss something in the permutation combination about a quantity which we call distribution problems. So if you want to distribute something, so how we can handle distribution problems? We want to distribute R objects into N boxes, and here R objects may be distinct, N boxes may be distinct, or R objects may be where the repetition is allowed or they are not distinct. So we can say distinct objects, or the objects may be identical, and similarly you can have boxes also distinct and boxes also identical. So there are different versions in which we can look at the counting problem depending upon what the problem is. So now in this video also I want to start by solving some combinatorial problem. Combinatorial word means we are associated in counting something using the notion of generating function. So I will begin with a simple problem, and so I will start simply by considering a set S in which the objects are distinct A, B, C. And here we want to consider the various ways of selecting objects from S. So in this case, we can select one object. So we can see there are three objects given in the set S, A, B, C. And we want, the question is to consider the various ways of selecting object. So the question could be, if I want to select one object, so we can simply say select one object or select two objects. And then we can also say select three objects. Now if I go back with my previous formulas, three objects, and if I go back my previous formula, in this case the answer will be 3C1, in this case the answer will be 3C2, and in this case the answer will be 3C3. 3C1 is 3, 3C2 is also 3, and 3C1 is 1. In this case the options that you are going to get, select one object, is either we selected A, or we selected B, or we selected C. So this is the possibility. In case you want to select two objects, so either you will take AB, or we will take BC, or we will take CA. And in case you want to select all at a time, so this will be A, B, C. So these were the way how we would have handled this problem using the previous arguments, that combination. Now let's understand this in the generating function form. So these can be understood by the notion of generating function, and in this case what I will do, I will create the parenthesis. How many parentheses I will create? Basically I am creating products based on the object. I will create this for object 1, this is for object 2, and this is for object 3. Now it is possible that we may select one of the object, and we will handle actually all these things all together in the generating function. So that is the beauty of the generating function. So in object 1, I'm going to write 1 plus a times x, 1 plus b times x, and then 1 plus c times x. Now what this generating function means? If we look closely, this one is actually ax raised to power 0. This one is something bx raised to power 0, and this is one is cx raised to power 0. And I will read this as a object is not selected. A object is not selected. So it is possible that when we are looking for the case, like say one object is selected, in this case we only selected B and A and C are not selected. So we need to consider all possibility. So for the generating function, and maximum in the set, we can see that A is appearing one time. So you can see there are three objects, A is appearing one time. You can also write the set S as 1 into A, 1 into B, and 1 into C. This means the multiplicity of the object is 1. They are appearing once in the set. So here what I say, here when I write in the generating function, Ax raised to power 1 means the object will appear once. So we can further say this ax raised to power 1 means a object is selected, or we can say a object appear once. A object appear once. Similarly, other will follow. Now we have created 3 brackets for object 1, object 2, object 3 in the similar way. Now if I simply multiply this generating function, so what will I have? You can see that we will have 1. So now 1 plus a times x, 1 plus b times x, and then 1 plus c times x. If we multiply this, let's first multiply the first 2 terms together and then we can multiply the next one. So this will be 1 plus a. So when I multiply a with this one, so I will have ab into x square. When I will multiply ax by this one, so this is ax and bx. So these are the 4 terms. You can simply multiply in any order, doesn't matter. And 1 plus cx. Now we multiply again. So we will see 1 plus. Let's first multiply this constant to all the terms. So you get 1 plus cx. And then we multiply this term with all this term. We will have ab x square. Then we can have abc x cube. Then we multiply this term with the remaining term, so we get ax, and then we multiply ax with the term, so we get ac x square. And similarly the last term when I multiply, I will get bc x square. Now currently these are in random, but let's arrange them in increasing order of the power of x. So we have 1 plus, club the coefficient of x raised to power 1 altogether. So we get a plus b plus c times x. And this is due to this cx, bx and ax. These are the terms. And then I'm going to club these similarly x square. So we will have ab plus bc plus ca x square. And then we will have the term corresponding to x cube. Now here you can see that the first term, I can also write it as 1 into x to the power 0 plus a plus b plus c times x to the power 1 plus ab plus bc plus ca x square plus abc x cube. Now here we will read these things as, how we can read these things? The coefficient of x to the power 1, this means one object is selected. One object is selected. And if I look at x square, so this will say coefficient of x square. In this, 2 objects are selected. 2 objects are selected. So we are solving this problem in one go rather than looking them separate, as we see that in case of the combination formula we made it other cases. But if we just write this in the form of a generating function, we are going to read all these simultaneously. We can see that. And 3 objects are selected. So x square coefficient is this one, and it is even telling us which are the corresponding or the relevant options are going to come up. So we have a plus b c. So and you can see that this is a plus symbol. So this gives relation with the addition principle. So this is OR. So if one object is selected, either it is A or B or C. If two objects are selected, either it is AB or BC or CA. If three objects are selected at a time, so ABC only one choice. So this is the expanded generating function, and here we have also learned the relevant cases. Now suppose if we don't want to know the relevant case, we only interested in counting. So if we are only interested in counting the number, associated with star. So what I mean by associated with star, I simply want to know that what is the coefficient of x to the power 1, or one object is selected, then what is the coefficient. In this case we will simply take all the objects as 1. So we don't want the relevant case. So in this case the above generating function reduces to, so we can simply say the above generating function reduces to, we will have again 1 plus, now a plus b plus c all are replaced by 1. So we will have 3 times x to the power 1. And then again you can see ab plus bc plus ca, if you just substitute them 1 1 1 1, so you get again 3 times x square, and here we will have 1 into x cube. So we can simply see this becomes 1 plus 3x to the power 1 plus 3x square plus x cube. 1 into x cube. And again the reading goes in the same way. If I now want to read this, so if I want to read whole of this one, you can again say that there are three ways in which one object is selected. There are 3 ways in which 2 objects are selected from the set. There is one way in which all the 3 objects are selected together. So you can read again in the similar way. This becomes, there are other ways of understanding this. This becomes a finite sequence. This corresponds to a finite sequence. And this finite sequence is simply because this is x cube is the last term, and the finite sequence is 1 3 3 1. But generally we study the sequences in infinite form, so we can simply write further. Corresponding infinite sequences add zeros in the remaining terms. So corresponding infinite sequences 1 3 3 1, and then add 0 0 0 0. So if I want to write this in the form of a generating function, you can rewrite again back. So this becomes, the first term is always constant, so this is 1 into x to the power 0 plus 3 into x to the power 1 plus 3 into x square plus 1 into x cube, and then remaining terms are corresponding to 0. So that's how if I look it in the reverse way, this is the corresponding generating function. And if I want to understand the coefficient, that these coefficient is counting to what thing. So we know that we started from the set S, which is for 3 objects A, B, C. And if you're not interested in knowing the actual arrangements in which, or actual selection in which we have selected, we can simply take up A equal to B equal to C as 1, and then we can simply look at the counting numbers. So now look at this one more example, and here the set S is given as S1, S2 up till Sn. There are n objects given in the set, and again we can see that S1 is multiplied by 1, so or I can simply write it like 1 into S1 and then 1 into S2. These are the objects. And let AR denote the number of ways of selecting R elements from the set S. I want to select R elements. Just like in the previous case, we selected 1 element, 2 element, 3 element. So if I want to select R element, this means we want to look what is the coefficient of x to the power R. So what exactly we want to look? We want to look coefficient of x to the power R. So this exponent was telling that R objects are selected. R objects are selected, or instead of objects we can even say R elements are selected. So this is how we have looked up in previous example. And now I want to simply find the generating function for the sequence. So again let's see if this is similar to this previous one. There are n objects, so first thing that we have to create is n parentheses. So we need to understand that there are n objects, and each object will have its own way of coming. So either that object may come or it may not come. 1 plus x to the power 1. Now I am not associating, remember in the previous case it was 1 plus a times x to the power 1. A object was coming, and then I said that you can take a is equal to 1 if we are only interested in knowing how many times one object can be selected. So you substitute a is equal to 1. So this means this becomes actually the generating function where I have considered a object. So similarly, now I am simply taking S1 equal to 1. The only thing I can write, this is corresponding to S1 object or S1 element. This one is corresponding to S2 object, and the last is corresponding to Sn object. And each object is maximally appearing one time. So this becomes the generating function, and which is simply 1 plus x raised to power n. And now we can simply, using the binomial theorem, r goes from 0 to n, we can have n choose r, x to the power r. So that's the expression we have. And if we just compare it with the generating function, because left side when you multiply it's going to give you something. So we have a r x to the power r varying from 0 to infinity. And so this is what we are expecting to know. So whenever we multiply this one, you can see the first term is 1 1 1 1. So when you multiply, you are going to get r equal to 0. A naught will be going to give me the coefficient which is corresponding to x to the power 0. A naught will be 1. So basically this is the sequence that we are expecting to know, AR and so on. And we have found that this is same as r goes from 0 to n choose r, x to the power r. So just comparing by coefficient, we can simply say, comparing on both sides, what do we get? We get that AR, this is equal to n choose r, and this n choose r is valid whenever r lies between 0 and n. Whenever this r exceed this n, so whenever this r exceed this n, in this case this is going to be 0. So that means this infinite sequence that I have written here, actually this will be a finite sequence as I have explained earlier. And so we can simply write that this is 0 whenever r is greater than or equal to n plus 1. And this becomes AR is n choose r. This becomes the same formula which is the formula for our NCR. So this is same formula for NCR. Now again in this problem we can look at this set, and in this case 2 times A 1 times B, this is like a multi-set notation. So, and I want to find the ways of selecting objects from S. It has not said that how many objects we have to select. That means we just need to again consider the possibility 1 object is considered, 2 object is considered, 3 object is considered, and so on. But if you can see from the set, the total number of objects, if I consider all, there are 2 A's and there is 1 B's. So in total there are 3 objects. In total 3 objects are there. That means we can select either 1 object. So that's 1 object is selected. 1 object is selected. This is what we can answer. Or 2 objects are selecting. 2 objects are selected, or 3 objects are selected. And this is the question. So keeping in this mind, let's consider the generating function. So here we will construct a generating function for this. In fact, in my multi-set notation, I have given you this one as R1 into some object, and then let's say R2 into some object. So when we say R objects are selected, so R objects selected means that R sum should be R1 plus R2. So when we say 1 object is selected, either R1 is 1 or this is 1. If R is equal to 2, then either both are 1 1 or R1 is 2, this is 1. So this is the general notations for the multi-set. You can refer this in my previous video. Now for the generating function, this is very clear. There are 2 objects first of all in the set. So we will have 2. So this is for A object and this one is for B object. And we see that A object is appearing 2 times. So it may appear 0 times, it may appear once, it may appear twice. So this is what it means. So for this we will have 1 plus x to the power 1. It appears once and it may appear twice also. but the B object is appearing once. So either it may not appear in the generating function while in the counting, or it may appear once. So this becomes the generating function. Now when I multiply this, I will get 1 plus 2x plus 2x square plus 1 into x cube. And so from here we can see one object is selected. One object is selected. For this the answer is 2, because in this set we have been given the set as 2 times A and 1 into B. You want to select the two objects, so either this object could be A or the object could be B. Okay, then we have two objects are selected. So if we have two objects are selected, in this case the answer is 2 also. Now when I look at the relevant cases, either AA, so two objects have to be selected, either you select AA or you select AB. Okay, we cannot select BB because BB cannot appear 2 times. So these are the two possibility. And in case we want to say 3 objects are selected, for this case we have only 1. And here in this case, the only possibility is 2 A's are selected and 1 B is selected. Order does not matter, since we are not doing this as an arrangement problem. This is simply a selection problem. So this way we can understand the generating function, and they are very helpful in counting the problems. So some more examples and some more typical problems I will cover in my next video.